In this video, I'm going to be going over Lab 4, the Grid Navigation Lab. So what this lab entails is that it's just going to reinforce your understanding of methods and 2D arrays in Java. So essentially what you're going to be doing down here is you're going to be creating an original grid that has walls and then a path on the inside just to showcase that this is what we're starting off with. And what you're going to be trying to do is make sure that you have a placement on that grid of two obstacles randomly generated, one that is a target, and then one that is the actual robot that we're supposed to navigate to the target with. So what we're actually going to be using in this specific lab is you're just going to download this file, which has starter code for you in the structure of what you should be using. And then you can either choose to copy or paste the code into your project folder, or you can just download it and drag it and drop it into your project and just change the package details. Inside of the program requirement here, what we're actually going to be using is we're going to have our constant static variables in Java here. And we're just going to be assigning to these constant variables our emojis. For Windows, that's just going to be the Windows key and that period symbol. And then for Macs, it's just going to be Command plus Control and space. Some of you guys may already have like a built-in button on your MacBook that allows for an emoji to pop up. Then what you're going to do is you just want to initialize that static value or that static 2D array of strings, and you want to name it a grid before the main method. And then we're going to make sure that the size is 5 by 5. And we're not going to assign any value to it yet, but we'll use this method for that. And then we're just going to initialize just the starting point of where the robot should be beforehand. And this is just going to be at position -1, -1. This is what we use to kind of just declare the value before we modify it later on. Then what we're going to do is we're going to have an initialize grid built-in function here. And this is going to just make sure that we align the wall and then also the path on the inside. You're going to use a nested for loop and an if-else statement for this. We're not going to hard code it. And you can also use the or operator as well. Later on, we're going to have a built-in method here that is called placeObject, and this is where we actually are going to be placing our specific objects and also our robot and target zone. And then later on, we are going to display, have a function or a method rather, that's going to display um, the original object or the original grid as well as the modified grid afterwards. So this should be used as a repeated function. And how the implementation details should look like is we have initialize grid, print, print grid, place object, print some statement like warehouse with objects, and then we're going to print grid again. Then later on here, we have a required method. This is just going to implement the following method structure in this way. And this is pretty much just how it's structured out. We also have your helpful resources here located with all of our lecture notes as well as the video walkthrough that I do. And of course, the video will be placed here for Lab 4. All right, so we're going to go ahead and get started. All right, so now the first thing that we're actually going to do here. And hopefully you can see, I know it looks a little different than what we have for our IntelliJ, but this is just to show you with the emoji aspect of it. But this is the file that you should have here. Note that you won't have packaged videos. This is just for the video that I have. This is just where I store the code that I have for the videos. But you will have everything that has public class, warehouse, all the way down when you download the starter code. Now what we're going to do is we want to put all of our constant variables here. So I'm just going to go ahead and do that. So we're going to first have statics. That way it's going to be something that is updated. Um, and the reason why we have it outside of the main is we want this to be available to all of the functions at the present. So we're going to make this our constant variable. And then what we're going to do here is we want to actually have some emoji here, and I'm just going to place the wall there. And what you'll notice here in the instructions, it says that you kind of want the wall to have a space. And so that's just for formatting purposes, but these are the walls of the warehouse here. Now, the next thing we want to do is just get our path right. So we're going to go ahead and create our static path, and we're going to use final for our constant variable here. And we always want to make sure that it's uppercase as a constant variable here. And so I'm going to have in quotes my path, and I'm just going to, if you put inside of your aspect just some square, I'm going to use the brown square and you do a space there, then this will be what is on the inside. This is going to be considered your open path. Oops. Yeah. All right. Now, in the next part of this, this is where we're going to want to get our robot, our obstacle, and our target. So we're going to do the same thing, make sure it's static, make sure it's final, and we're going to also set this to be a string. And that's just because we're using emojis, these are considered strings in that way. So I'm going to go ahead and type in some robot here, get our robot image and have a space and a colon. Right on. All right. And then the next thing that we're going to actually do next is get our obstacles. We're going to do static, final, string, and then we're going to have obstacles. All right. And here is where we are actually just going to display our box. So we're going to use this box here with the space. And this is just going to be the obstacles slash shelves. Now, the next thing we're going to have is our target. So we're going to do static final string target. And we're just going to assign to that a target. And we want to make sure the space is in the back, not the front. All right. Colon. And then here we're just going to have, this is our delivery zone. This is where we want our robot to be. Now, the next thing we're going to have here is the last item in our, like the last item in our variable listing here, and that's going to be the size. And for that, since it's not an emoji and we do care about it being an integer, we're just going to do the same thing, static final. Instead of string, we're just going to put int, and we're just going to create a variable called size and set that to be 5, right? And so this would be size of the warehouse. All right. So now that we're done with these constant variables, the next thing we actually want to do is actually place or create our 2D array with the same size. So here's what we're going to do. We're going to have this be static. So it's accessible in all the methods, not just specific to an instance of this class. And that'll make sense to you later. But now we're going to do string. So we're going to do open close square brackets to indicate that we want to do two arrays here, a 2D array here, an array within an array. And then I'm going to name the array grid. And then I'm also going to initialize the array so that it allocates the space that I want. So in this case here, I'm just going to do equals new. So we're going to use that new keyword, and we still have to declare the type of the 2D array as string. And then here, I'm just going to go ahead and make sure that I finish off my array size here and my colon. And now I'm going to go ahead and my array structure and the colon. And now I'm going to just go ahead and add in the size. So here I'm going to go ahead, put in my variable size, and the same thing here. So what this is doing is it's allocating space for a 5x5 2D array here. So now that we have this process here, this is just where we're going to store the warehouse layout. Now, the next thing that we're going to do is we want to now store the position of where the robot is. So let's get this up. All right, so this is going to be static, but also not constant. So we don't need to uppercase this. So these next variables, we're going to make sure it's accessible to all the methods and modifiable in all of them in the same way. And they're also going to be global. But in this way, we're just going to do robot row here. And we're just going to set that first one. We're going to set it to -1 just as our default value. And we're going to do the same thing here for robot column. We're going to set that to -1 as well. So now that we have finished with this section here, we finished with our constant static variables, we finished with our 2D array, and we've also finished with our global variables here that are not constant, they're not uppercase, but we do default saying that the robot is going to start at position -1, -1. Now, the next thing we're going to move on to is just going into the initializeGrid method. So the first thing we're looking at, we're going to uncomment this out, this main method here. And then we're going to go down to our initializeGrid. Now, in this grid, we know that it's not going to take any parameters, but we are going to have to call it to display some information. So in this case, we know that we're going to have to use a nested for loop because it's going to be having to iterate through this 2D array. So I'm going to go ahead and just structure out my for loop like I like to. And then what's going to happen here inside of our inner for loop, and that's what this is called, is we're going to just start off int, and we're going to let this be the row. So we're going to create a variable called row and assign it to be 0. Then we're going to make our condition be row is less than. And since we've already declared the size of the actual array, we can actually just use this global variable here, this constant global variable that's not going to change. So we'll go ahead and do that. And it needs to be named the exact same. So we're going to say row is less than size. Now, the next thing we want to do is just increment row. So we're just going to do row plus plus. So that is for the outer for loop. Now we're going to do the same thing for the inner for loop. And this time it's going to be called col for column. So I'm going to just say col is assigned to 0. And then we're going to do col is less than size. And then afterwards here, I'm just going to have my colon, and then I'm going to do col plus plus just to increase the colon object once it's done the first iteration here. So now we have our outer for loop and our inner for loop. Now let's look at how we should structure this. If we look at the grid or the visualization in the lab, let me get that up. Okay, so if we're looking at our grid right here, and I'm going to try to make this a little bit smaller so we can see the code with it. All right, so in this case here, if we're trying to just get the walls to be on the outside and the path to be on the inside, how we can break this up is when we know that this is going to be a 5 by 5 grid. It means we have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So that just means that the wall is at whenever row is at 0 or column is at 0, that's a wall, or whenever it's the size -1. So we have up to 4. So we have the row 0, row 0, or row 0, column 0, row 1, column 0. And this whole thing, we have our column being 0, and we know that it goes through each row. Then on the other hand here, we also have where it has to be where the column is size -1, which is just 4. And so we know that whenever column is size -1 versus size -1 and row will be interchanging, then we know that's also going to be the wall there. So we want to look at, and if you guys remember in the instructions, it says that OR operator is going to be our friend. So anything else on the inside, we don't really care about at the present. That'll just be the path. What we do care about is assigning the wall. So we know that we have 0, 1, 2, 3, 4. That's row 0. And then the last row, which is row 4, column 0, and then the last column, which is index 4. That's what we're looking at. So that's what's going to be in our if condition. So what we're going to say here, stab it in, if row is equivalent to 0 or row is equivalent to size minus 1, because we do know that length. You could also get the length of the array and do minus 1 too, but this is much easier. And then here we're going to say if row is equal to 0 and row is equivalent to size minus 1, or column is equivalent to 0, or column is equivalent to size minus 1. So now we have our first condition here, where we're checking, making sure that it gets our full outline of the square. So now that we have that, how do we go about updating that array? Well, similarly to when we want to update 1D array, we're just going to assign whatever value is being stored in wall. In this case, we're going to use wall, the constant variable here. We're going to assign that to the specific row and column if this condition is true. So what we're going to do here is we're going to say grid, both of our open close square brackets for the first, for both the 2D arrays. And the first one we're going to put row, and the second one we're going to put column. Then afterwards, we're just going to initialize it with our constant variable wall. So now all of the items should be on that little square outwardly. Now, the next thing we're going to do is we want to do our else statement here. So inside of the else statement, we're just going to have our grid again. And this is going to be fairly easy because we know that we already have the wall. The rest is just going to be the path. So anything else, we'll just put the row, the column, and then we'll put here the path. So after this, we now have a good grid that really just initialize our grid. We know that we have our wall and we're going to have our path there available. Now, this is great and all, but we first also need to be able to see the grid. So even if I ran this, we wouldn't be able to test it properly unless we display it out. So let's go ahead and work on that print grid function there. So now that we are in this printGrid function, this is going to be quite similar to what we've had before. So we're going to use our nested for loop and we're going to have some if else statement. So let's go ahead and structure that out. So here I'm going to again make sure I have my for loop in Word and then my other for in Word here. All right. And now inside of this for loop, I'm just going to initialize the row again. We're going to set the row to 0. Then we're going to have the row is less than size, and then we're going to do row plus plus. All right. And now the next thing that we're going to do is we now want to do the same thing for the bottom row. So what we're going to do is we're going to say in col equals 0, col is less than size, col plus plus. All right, so now we have our nested for loop structure. Let's now go ahead and figure out what we should be displaying out. So in this section here, if we want to be able to print out the grid and we want to actually see it, we will have two conditions first. We want to check to see if row is equivalent to our robot row and also the column is equivalent to the robot column. This would indicate to us that potentially there is not necessarily going to be a grid yet. So that's saying if row is -1 and column is -1, then we're just going to print out the robot. Otherwise, we're just going to print out the actual grid. So let's go ahead and do that. So we know that the name of our variable is going to be robot row and robot column. So we're going to say if if the row is equivalent to robot row and column is equivalent to robot col, then inside of here, we're just going to print out system.out.print robot, our actual emoji here. Else, we're going to display out print, and we're just going to type in here grid row and then grid col here. All right. So now that we are done with these, the next thing we want to do, since I'm using print, is I just want to have an ln print at the very end to just give that space in between each grid. So I'm just going to do system.out.println, open close parentheses, and a semicolon at the end. Now, the next thing that you are actually going to do after you do the print grid here is you're going to save your work and let's go ahead and run it to see what it looks like to make sure that we did everything the way that we wanted. So first things first, we already see that we have this information here, but there's something not right. It's all on one line, and we really want it to be separated like this. So let's go ahead and see where our issue is. So the issue is actually going to be right here where I accidentally didn't place this println here. It needs to be inside of the outer for loop, but outside of the inner for loop. That way it prints out our first row here, and then we shall get, let me zoom in a bit so you can see this. That way that line of code, what it's going to do is it's going to print out this lower grid first, this first part here, give us a new line, and then it should look like this, where we want to get this next row here, new line, next row, new line, next row, new line, and then last row. So now when we run this, that's what should be our outcome. And that's exactly what we get here. So we see that we do get this and it works well. So now we're going to move on to actually placing the objects onto our grid. All right, so when we work on actually placing the objects on the grid, it's actually a lot easier than you would think. But before we do that, just to make sure we don't forget to do this, we're going to uncomment out the place object as well as the print grid since we already fixed the print grid. And I'm just gonna scroll down to the place object. Once this is called, the first item that we want to place is going to be the obstacle. And from the lab instructions, it says to place it at index 2, 2. So we're going to go ahead and update the grid. Hence why we actually created it to be static. Now we can actually access that grid without having to pass it into each of these methods or even having it be assigned to a specific object of a class. Here we can just update the grid and it will get changed throughout all of this. So now when we call print grid, it will already be updated since our grid is static. So every function has the ability to, at this point, change it if it accesses it. So in this case here, when we have the grid, we're just going to put index 1 here and then index 3 for the other obstacle to align with the instructions. And then afterwards here, we have place obstacles. Next, we're going to actually go ahead and place the target. So now we're just going to assign the target at grid position 1, 1, where the robot should finally go. And then finally, we have here where we're just going to place the robot. And we're just going to do grid. And for this, it does say that we want the robot's position to be updated to 3 and 1. So instead of us actually using the grid to update it, since it's not on there, and we're actually using this process of the robot row and robot column for our print grid. So if it's the -1, then it just prints out the robot. Otherwise, it's just going to print out the grid. Well, this works out great. So what we're going to do here is instead of the grid, we're just going to go ahead and say robot row equals 3, and then robot call equals 1. And then this is just great. So now we're done with this part here, and we can actually look and check to see if what we did prior worked. So we're going to go ahead and save this. And what should happen here is if the row is equivalent to the robot row now, if it's 3, and then that column is going to be 1, then we're just going to display the robot there. Okay. And so what we're going to do is run this. And I think I want another. Let's put some space here. Oh, I had an extra semicolon there that needs to go out. All right. And then I also want to give that extra space there. So we're just going to go ahead and have a print line. Yeah, we can actually keep it in this function. That way it's the same. So we're going to have our print line right here after this for loop. That way we have a space between our grid and it's not so jumbled up like this. All right, so now when we run this, we now see, okay, our original grid and then our updated grid. And we see that our robot gets placed exactly where we want it to be. Now the next thing is to check, does it match the example output that Professor gave? Yes, it does. Now, one of the things that I wanted to bring to your your thoughts is if, for example, you did not do the spaces at the beginning here, let's say we forgot to do that there and we did save, it will be formatted very weirdly. So you want to make sure that while you're doing this, even for your project, that when you're formatting, think about adding in an extra space at the end there. And there we go. We have this here and then this below here. So it works out perfectly fine. Now, the next thing that you're going to do is just test out these parts, and you can use this always to reference back for your project. And I hope that this video helped you. Let me know if you have any questions, but this is it. We're done with Lab 4 and the warehouse navigation system.